Okay, I think we're ready to go. I thought what we'd do today is finish up our little talk on the MultiMaterial. I did get the Prusa MMU2S to work relatively reliable. I haven't printed any super long prints on it. Everything you do print with MultiMaterial does end up being a longer print than it normally would, just because of the transition from one filament to the next and back and forth, and that might happen, you know, multiple times per layer even. So even I did load up a benchy. I think it was a 2-color benchy, and it was a 7-hour benchy, for instance. So I haven't printed any really long prints, but I have gotten several in a row with no intervention from me. Morning. I'm glad we have some people. We have a couple, two viewers, at least one in the chat. What we're going to do is I'm just going to wrap up kind of a few thoughts, and then I've got SolidWorks open over here, and we're going to look at how you can do some topology optimization, which it can be used for 3D printing. It could be used for just manufacturing in general. And there's two broad categories of this. What this is maybe you've got a bracket. I'm going to model a bracket, so that's what I'm talking about, a bracket. You got a part, and you want to create it. You know, you could just cut the thing out of plate steel on a water jet or something like that, and you've made the bracket, and you're done with it. But maybe this bracket needs to go on, you know, a space vehicle or something where weight is extremely important. Or airplane even, and you want it to be strong enough but as light of weight as possible. So topology optimization and its counterpart generative design are that process, or at least a process to do that. And so what you do is you go in and you build the bracket in different ways depending on what you're doing. If you're doing generative design versus topology optimization, today we're going to do the topology optimization. And then the software will eat away at it in topology optimization. It will eat away at it and iterate to try and find the minimum amount of mass that you need and where you need it in order to support whatever kind of load that you're trying to support. So it's sort of a simulation thing. Generative design, like Fusion 360, almost does the opposite of that. You give it some connection points, and it grows the material between those connection points in a way that would support the loads. And so we'll look at the SolidWorks one today. And depending on where we are, I might also show you a little Tinkercad demo of how we can prepare some parts like the ones I'm going to show you here, these guys, just so you get an idea of how you might go about doing that. So let's look and wrap up our printing stuff first. So here are some things I printed. So I printed these sets. I made all of these things in Tinkercad just as kind of simple 2-color. I didn't do any more than 2-color prints. I did do all of the colors just 2 at a time. So remember, this material upgrade thing has 5 inputs into it, and mine are all PLA, and they're just different colors of PLA. So it took many hours. So I probably didn't get an actual print for, I don't know, a day after I finished building the thing. It is a kit, so you have to assemble it all. So probably a whole day later was I able to get any sort of real print. And a lot of the problems, there were 2 problems. A lot of them came from just the filament I was using not being quite the right diameter. And this machine uses kind of its own Bowden tubes. So there's 5 of these tubes that lead into the machine. And the filament that I was using for one color that I kept printing with was just a little too tight, and there was too much friction in this line. So I fixed that by not using that filament. I switched it out for another one. I will more permanently fix it by changing out these tubes for a little bit larger diameter tubing that I ordered. So that should fix that problem. There was too much friction in the tubes and it just wouldn't pull the filament through. The other problem was a little bit like I had mentioned, that I was afraid of some of the tolerancing on the printed parts, and they were too tight of tolerance. They were just a little bit maybe over extruded or whatever. I did not print these parts; they were printed at the factory and part of the kit, and they just had a little bit too much or a little too tight of tolerances, and they didn't move very freely. And so I cleaned up the one in particular that had an issue. And so far, since I've done those two things, I've gotten, I hit print and it goes and it does its thing. I don't really have to intervene. Again, these were, this pile and this pile were 2.5 hour prints. This was a 40-minute print. So I did these things to kind of show you. So this set, let's just weigh them so that we can kind of see what you get when you do one of these. So we're on grams. Let's turn it where you can see it. So let's let it tear. All right. This is the amount of waste. 4 grams. I don't know 4 point whatever, but 4 grams. And the actual part that you printed doesn't even register. So it's less than a gram. So that's kind of the one issue, is that it can be, for really small parts in particular, it can be that the thing you print is actually less material than the waste you throw away. So that's one issue. Now in this case, we're talking 4 grams of material, 3 point something grams of material right now. So it's not that big a deal. It's so light that it doesn't register very well, apparently. Now it's dropped down to 2. But the point is that there's more of this than there is of the thing you wanted. But you can get around that, assuming they're small parts, by you just print a whole bunch of them. Oh, I saw it was teared at -2 for some reason. So you can print a whole bunch of them, so 12, 13 grams worth. And you still only have the one purge block that in this case doesn't even measure a gram. See if I can get it to, there we go. So it's like 2 grams, 2.5 grams or something. So you still only have the one purge block for no matter how many of these you can fit on there. So I think there's 10 of those. I did the same thing with these blue ones. Probably should have about the same, yeah, it's actually a little bit lighter, up to 2 grams. And I printed 20 of these little things. So, let's see if I can get them off of here just to measure them. Obviously, they weigh more than 1.5 grams. But let's see how much. So, 9 something grams. So you can kind of get some economy of scale out of this sort of printing. Now, these are actually relatively small purge blocks. Once you start building any height, these are very thin. Once you start building any height, those purge blocks get larger and larger, even if you aren't changing. In fact, you can kind of see this has the same pattern of colors that this one has. Actually, this is the bottom of it. So you can see where it matched up. Even if you don't have colors mixing on the same layer, you still have to print a purge block because it has to be built up, so that when you do need to purge, it's there waiting for you. Now, it's mostly hollow inside a lot of here. You can kind of see it's very, very sparse inside there. But you still have to have it. So there is that little bit of waste. I did mention some ways that you can purge to the infill. These parts don't really have infill. You can print like this could be something instead of just a rectangle. It could actually be a part. So you can kind of recover some of the lost material. In this particular case, you're still only talking, what was it, 4 grams, 3.5, 4 grams. So it's not like you're wasting that much material. But there is that to be thoughtful of, that this type of multicolor printing, where you're still using the one nozzle and all the different colors are coming out of that one nozzle, it does have a little bit of waste associated with it. There are other types. There are tool changers. I do not have a tool changer printer. They're pretty expensive. Maybe someday I'll manage to get one of those, but basically it goes in and there might be 4 or 5 tools or nozzles at the back, each with its own color, and your carriage is really just a holder for different tools, and it goes and picks up a tool that it wants to print with and snaps it on and prints for a while and puts that tool back and gets another tool to print a different color or a different material. Those don't have as much waste. They have a tiny amount of purge, just kind of like you purge before you start printing. So they do have a little purge, but not. They don't have to print a whole purge block. So there are that style of printer available. Let's see. I don't want to spend a whole lot more time because it does take, some special equipment to be able to do this sort of printing. These came out really nice. Oh, maybe, let's see if you can tell or not. So this is a textured build plate. I don't know if I'll be able to, you can see the texture there. That texture, so there are different textured build plates. It doesn't have to be a Prusa to have a textured build plate, but they're pretty interesting because the texture gets embedded as part of the print. So you might be interested in adding a textured build plate. So this is a PEI sheet, but the PEI has a little bit of a rough texture, and so that texture gets picked up. You can kind of tell it's in there. Maybe if I zoom in, yeah, you can see it there for sure. Those little sparkles are not sparkles; they're actually the texture on this thing. So it does create at least one surface, the surface that's on the print bed, as actually a really nice surface. You can't tell it's 3D printed. Now the other side still looks 3D printed. You could maybe turn on ironing or something like that to reduce some of the layer lines, but you do get one side that actually has a pretty nice finished texture on it. So that's a thing that regardless of if you're printing multicolor or not, it's really nice on multicolor because it kind of blends the layers together, or the colors together, without mixing them together, so that it doesn't look quite as start and stop between the two different colors. One other thing about printing before we do generative design is I was having trouble getting parts to stick on here. This is a PEI sheet, but they do need cleaning and refreshing from time to time. And I'm touching it everywhere, getting grease all over it now. So what you can do is clean it, wipe it down. And I was spraying this stuff just directly on the print bed, and it held down parts pretty perfectly, even small parts. Like these don't have a lot of surface area. They had no brim or anything. They were just stuck down for the entire print. Same thing, I think this one might even have less surface area, and it stuck down. Well, actually it went, yeah, that's the way it went. Stuck down the whole print, no problems. Just with using this, you actually want the cheapest hairspray you can get. And so this is the one that I use that's pretty good when I want to stick something down without having to take the bed off and really actually go and clean it. With this particular bed, what I have to do a lot of times is hot soap or warm soap and water, and then a little scuff with a steel wool pad to kind of refresh the PEI on it. I don't think I would use that steel wool on one of the flat PEI sheets. I've never done that. That PEI is very thin on most of the sheets I've ever used, and I'm afraid I would scuff through it. This one is actually kind of powder coated, so it's thicker on there. And so you can do that refreshing a couple of times. All right, many times so far. I've used that one many times. All right, I'll leave multicolor printing behind. We'll get back to printing. Remember, we wanted to print some ABS material because I want to work on a Voron printer. I'm trying to decide which Voron to go with. There's a really tiny one, a V0, that kind of gives you the effects of the Voron, but it's small. It's like super small print volume. But there's that, and then there's the regular, actually there's big ones, 300 millimeter cube printing volume. And they're not terribly different prices. They're a couple $100 different for the kits. I'm trying to decide which one I want to do. but I don't know yet. But we wanted to print ABS parts to build that. So we'll get back on that Monday, I believe, is what we'll try to print some ABS. I ordered some, so I don't have any. I don't normally keep ABS around that often, so didn't have any. So we'll try to print some ABS and see how that goes on Monday. So let's go over to SolidWorks. Where is it at? There it is. So let's build a part first. So I'm in SolidWorks part file. I never remember how to get this thing off of there. I think it's in, if I don't view, it's in view. I just don't remember which one it's called. Command Manager, that's it. All right, there we go. So if you go to view toolbars, it's off the top of your screen, but at the top of this little drop down is Enable Command Manager. If you and it's going to always auto pop up. You can turn it off in some kind of preferences, maybe in this customized menu. But if you unenable it, then it kind of makes you have more room on your screen. It's really good for laptops because that thing takes up most of your screen. Particularly if you have this also over here, you can at least drag this smaller because you don't need that wide. We will need to widen it here in a second, though. All right, let's build a part. File, new part. I actually wanted the toolbar, though. It took the toolbar. Maybe I have to keep both of them up. Oh, that's annoying. Because I want that. Oh, wait. So this is Command Manager. That's just, I don't remember what this little thing over here is, but I wanted it minimized. We got it minimized. I don't know the best procedure to do that. Let's do on the front plane. Let's just make like a shelf bracket type thing. Nothing particularly fancy. Something like this. Okay. And let's put some holes in it. So let's just put holes like it's going to screw to the side of something. It doesn't really matter what it does. That's not the point. Let's make these, looks like 1/4 inch. I guess I'm in IPS. And then let's just put some round, let's make that 3.5. 1/2 inch there, 1 inch there, and let's do 3 inches there. And then let's do the space between these holes. Looks like 2 inches would be good. And then let's put, that one to there as 1/2 inch. All right, so there's our little bracket. Let's make it out of a 1/2 inch plate of steel. All right, so now we've got, you could just go get you a 1/2 inch piece of material, laser. Well, you have to have a big laser, but you could laser this. You can do that, or water jet it or whatever, and make the part. Let's assign it. You know what? It takes forever to assign material, but we have to assign material for this process to work. It has to know what kind of material this is going to be. So we do have to assign a material. Where's the material manager? Oh, we can do it on the next thing. All right, so you design your part, and then, it looks like I've turned off my simulation manager, so we'll need our simulation add-in. Let's see, let's turn on simulation. So it does, if you disenable or unenable those add-ins, it'll boot up SolidWorks a little faster, but then if you do want one of them, it has to go and reload it, so it'll take you longer later. I had disabled most of them just because I don't use them regularly. I just use the design part, and so it takes a little bit extra time to load them up when you want them. All right, there's simulation. Still loading. All right, so we can do a new study. And there are I guess I'm going to have to add in more than just the simulation, because right now I've only got static available. All right, let's see which ones we have to add in to actually get to the topology optimization. Let's see. I don't know if it's shouldn't be motion. I wonder if it's shouldn't be any of those. I guess it could. It should have just been that one. But I don't know which one it's not. Doesn't have that. There's flow simulation. It shouldn't really be that. Shouldn't be that. Cam. I don't think it would be in the cam. That's for more processing G code. I don't think it's composer. Plastics. It shouldn't be plastics. XPS driver. I don't know. We'll have to see what's going on here. Maybe we won't do this. Maybe I could, while it's doing that, I'll look over here and see. Let's see. Well, they have a separate one that whenever you search online, it brings out a separate one that's not the actual one built into SolidWorks. If we can't get it to start up, then we'll do the Tinkercad thing and come back to this once I figure out why it's not letting me do our topology study. Oh, there's a add-ins tab. I'll look in there too if it ever wakes up. So this is the problem with at least running SolidWorks on this computer and a lot of other things at once. It gets bogged down some. Let's see. Still hadn't really woken up. Yeah, see, and I don't have any of the others either, so I'm not sure why. Although it even says Topology Study 1 as the names, that's kind of strange. Won't let me do the topology studies. Let's just do a couple of things to check. Let's save it. You know, that shouldn't actually matter, but who knows? Maybe it'll kick something into gear. I wonder if the version of SolidWorks that I have now doesn't have a license for these anymore. I guess that's possible. Because these, the thermal and all those are in the premium version, which once upon a time we had. I wonder if that has changed. Oh, I'm stuck in that thing. Yeah. Let me just check and see. if we can really figure out where it has gone. Because, well, you know, I thought of that, but it shouldn't matter because you can normally apply the material afterwards. But I did wonder if it matters if we have a material specified. So let's just check, because I do have a steel applied now. Now it's still stuck on only wanting to do static study. What I'm going to do is I'm going to enable some more of these and then reboot it, which will take forever, but we'll go ahead and do it. And there's, because it didn't actually add the flow simulation either. So we'll put in some of these extra ones and reboot SolidWorks just to see if that it shouldn't be, most of these shouldn't actually matter. Feature works, I don't know. I think that's more for recognizing shapes as certain features. We'll put the motion in there. Routing is for wire routing. But we'll put all these. Let's just check them all. Check them all. All right. I don't know what that one is. Oh, that's a published one. All right. Got them all now. So we'll come back to SolidWorks because it's going to be thinking for a while. We'll actually restart it. In the meantime, let us move I can't even move SolidWorks right now. It's busy running add-ins command. Let's just show how you can make some multicolor parts, because even with one nozzle and no accessories, you can make parts, print them as individual colors, and then put them together. So you can do it that way. So let's just do a quick way of how you can do that. How I can make one of these or something like one of those. So not a very complicated part, but it'll give you the ideas of things you need to keep in mind. Yeah, my SolidWorks license, it's a network license, and so I wonder if something on the network side when it went to retrieve the license has changed since the last time I used it. That is possible, because I don't control the actual license. It's controlled by the network. So I am wondering if that is, wow, it's still doing. Oh wait, I wanted to close it though. Maybe it'll close and I can restart it. But yeah, that's kind of what I think, is that either I just don't have quite the right plugin installed somewhere, or the network license has changed, because it is the summer and that is when they change out the licenses, and maybe it has somehow kind of reverted to a lower level license. All right. So let's say we want to make one of these style things. So a little token with a number on it. We're in SolidWorks. No, we're not. We're not in SolidWorks. We're in Tinkercad. Let's get all of Tinkercad on the screen. There we go. Let's make, I don't know what shape. Let's make a polygon shape one. And we can pick octagon. We want octagon shaped things. And we can, 20 by 20 is probably fine. Let's make it much thinner than that. 3, yeah, that'll be fine. So this will be our body of the thing, and then we want to put some text on it. Now, Tinkercad has text where there are, 4 different fonts available. If you want to print or create with other fonts in the, I think it's in the shape generator featured. No, it's in all, I think. What page is that on? I'm off the screen. Let's see. This one, custom font text. So this one, you can drag a font SVG file, .svg, so like a vector graphics file here, and then you can create any sort of font that you have a SVG file of, and you can make SVG files using online tools if you want to, of a font like a TrueType font or whatever. So you can create other fonts, is my point. it's just a process. You have to go and basically import them as a picture, and they get used as more or less vector graphics at that point that can be extruded. So you can create other fonts. We're not going to worry with that today unless somebody really wants to know that. This one can be, I've got a 10 and 100. Let's make a 50. So we'll change our text to say 50. We'll make it only a height of 1 millimeter. These are all in millimeters for me right now. And we'll make it much smaller so it actually fits on our little octagon here. I made that one 20 by 20, so let's make this, let's see if 15 by 15 will fit. I don't know if it will. I think it's going to be too big. Yeah, we have to make it smaller than that. Let's do 10. It looks too small. Let's do 13. 12. We're just guessing. All right, and then let's center this thing up. So I've highlighted both of them here. And then this tool up here is align. And so these let it align to the center and then center of the height. So now it's in the center of this octagon. Let's copy that. So Control D to duplicate it and then flip it over so that it can be on the bottom side also. It doesn't matter, but that's what I want. Put it on the deal and let's align all of these. Okay, now let's move this guy out of the way. Select these two and group them. Copy them. So Control D is duplicate. You could, I guess you could do Control C, Control V, but Control D is duplicate because we need one of these to be set up as a whole to cut away from the part that we're going to embed the actual one in. So now we'll align these sets and group them. So when you group holes with solids, it cuts the, it's a Boolean subtract. So there, now we've got the, you can kind of see where the 50 used to be. And now let's line everything back up. And now we've got two, oh, did I group those? I think I did. Make sure I grouped. Yeah, I grouped those. Now we've got two parts, two models that have, one of them is the blue octagon and one is the red 50s. And so you would select one. Here's the blue. We could name it something that makes more sense than the random name it gives it. So export just the selected shape. So you get one file. And then pick the other one. So in this case, the 50. Export selected shape. And you get this next one. And now what will happen is, since you've lined them up and cut away the hole that the others go in, you can print. Now this one, this particular one would not work without a multi-material. These are intended to be printed simultaneously because of, you couldn't print this, right? Because it's floating above it. You'd have to actually connect those together to, or print them as two, actually separate them, print the one, print them separately so you can insert them later. But this is how you would do it if you were going to print it as a multi-material part. Let's see. Oh yeah, we got all kinds of, let's restart SolidWorks. Actually, let's actually restart it from the very beginning. Oh, I didn't want to send an error report. Oh well. There we go. All right, so we'll let it start and maybe, see, it's doing the education edition. I don't remember if that's what it always said before. We'll have to check on that because I really don't want to lose my premium features that we used to have. So we'll see. So this part, now I've got actually two STL files. So we can open up our slicer. I'm using Prusa slicer for this particular one. You probably could make the MMU work with a different slicer, but it's going to be more difficult than it's worth. Let's make this where you can see the sidebar here. Okay, like that. So here in your printer options, there's one, so you can use the printer, even though it's got the multi-material attachment set up on it, you can still use it as a single color printer. You just have to change to tell it that you are going to use the single version. So MMU2S, that's the multi-material upgrade 2S. I don't know why the S actually, the special, I don't know. Second, I don't know. SolidWorks just opened. So you do have a single version where when you upload the file to the printer, it asks you which one of the colors do you want to print. So you can still have all your colors loaded and everything, and then you pick the exact material at the time you're going to print the file. That's not what we would want here. We would want to have the multi-material engaged. This is a copy of the profile for some reason. I don't know why. Let's see. There's our two STL files. And it recognizes that there's two files, so it must be a multi-material since I've got the multi-material printer set up over here. It gives you a rough idea of where the purge block is going to be. This is way too large. It's just a guess. And then what you can have is these over here are the different colors I have loaded. So I have a white, a gold, red-ish color. It's more orange, blue, and a yellow. Yeah, that's what are loaded in these particular spots. And so you can choose which colors, do you want a gold coin with white lettering, or do you want, I did blue and yellow, red and yellow. These others aren't going to look that great with yellow text, but we could maybe we could try. So you pick the nozzle you want to come out and print that part. And then this gold and yellow might work. That looks a little bit more contrast. The problem with my white filament that I'm using is that it's very milky, so it's not translucent exactly, but it's enough that it doesn't purge very well. So the default amount of purge tower doesn't actually get all the other color out of it, so it gets tainted. Oh, you can see that. Where'd I put that part? I did print one other part. I did print part of this, but it came loose. That's why I started with the hairspray. It's because I was getting parts come loose. But you can see how it's perfectly white when it doesn't have to mix, like right in here. But then this is the same color at the top, but it's having to purge this little bit of gold. And you can definitely see there's a tint to the yellow, so it didn't purge well enough. Same thing on the bottom where his feet were. But he came loose. He didn't have a lot of surface area holding him down, and that was before I was spraying the bed and had cleaned it and everything. So at this point, you'd probably want to put a whole bunch of these out there. Oh, it's outside the printed area. Let's rearrange it. I don't know that I want the purge block in the middle, so you kind of maybe do some manual rearranging a little bit. Take as much time as you want for that. And then slice. And there's the actual purge block. There's the print. It says, let's see, an hour, probably, close to 2 hours by the time it takes to heat up and everything. So 2 hours is not crazy for 10 of these. You could probably print them faster without the multicolor, but then you'd have to paint them or whatever. So that's kind of the general process of how you go about getting this thing to actually work, from creating a model to putting it on the print bed. The next thing is you export and send it to your printer. Let's see if SolidWorks has agreed with us that we should be able to do some simulation stuff other than static simulation. It may be that my license has reverted to some lower level license. I need to fix that, which would be a pain, but we'll do it. I won't be able to do it today. So just to simplify things, let's just make a rectangle versus the bracket, just to speed it up here. So there's our part we want to work on. And let's go to simulation here. I do have the motion. All these others are in here. I think it's still loading up the simulation add-in though. I wonder if it didn't engage them. We'll give it a shot. New study. Nope. I think it must be the license has changed on me because like not even that long ago all of these were available. So we'll have to see what's going on with that. It looks like it does have something to do with the license changing. I might need to update my license or something. I don't know. Well, we can't do that. So I'll describe kind of what it will do in case that the license is just not available right now. But what it will do is you will put a load somewhere. So if this were a shelf, I'd probably put the load on this top surface. And I would put some constraints. It starts out very much like doing a finite element analysis of it, because it does use finite element to go through its iterations. So you go in and you put a load on top or wherever your load is. We would have to put some constraints. So we had those holes. I would put those holes as the fixed constraints. And then you tell it a few other things. Like, are there any symmetry planes that, in this case, we would have a plane of symmetry that it could kind of half the model and only have to work on half of it at a time. So we could tell it that. Are there any regions that you want to preserve? So those holes, I can't eat away the holes. I have to have those to mount the bracket. I probably need this top surface to be preserved because that's what's holding the load. So you give it any regions that you want to preserve. So I would click the holes and the top plate and tell it how deep of a preservation that you wanted. So in millimeters or inches, whatever your units you're in. So that you have some solid material that does not get eaten away around anything that you want to be preserved. And then you can tell it a couple other things like some manufacturing constraints. Is it going to be demolded? So if it's going to be an injection mold type part or a cast part, it's got to have a way to demold. And you can tell it which, if that's true. In additive fabrication, that's not necessarily an important thing. You're not molding and you can pretty much fabricate in any direction. You can tell it what goals, are you trying to create a reduction in weight? Typically that's what you're trying to do, but there's also, are you trying to get the maximum stiffness to weight ratio? Or are you trying to get, some other particular goal? So there's a couple of goals you can choose from. You can tell it how much weight reduction you want to aim for, 30%, 20%, 50%, whatever. And then it will start running the simulation once you hit run. And it will go in and it will eat away iteratively at your part. And your part that you end up with it's going to be very lumpy and everything. You can create a solid model from that. Typically what you do, you don't actually use that part. You use that part to go back, and it's more like a template that you can use to model a actual part. The Fusion 360 one creates parts that are, since it's generative, where it starts is you kind of start with those constraints, the holes and the surface the load's on, and it grows the material between those surfaces as needed. So it ends up more spider webby, and you can print that part directly. Now, additive fabrication and generative design or topology optimization don't make as much sense when we're talking about FDM, so the plastic printing. Most of the time, you can reduce the weight just by controlling the infill. You can just change the infill amount and control the weight that way, assuming that you still have the strength you need. So FDM in this sort of process are not exactly one-to-one on usefulness to each other. This process is assuming that what you're actually going to do is you're going to print this in a metal. So it's going to, or maybe a nylon, you know, one of the laser type printers, a SLA printer, where it's going to be solid everywhere. It doesn't have a hollow interior. It's solid, and the material is much less layer dependent on, like, the shear between the layers being the weakest part. It's assuming you're using one of those SLA or laser sintering of metal, you know, one of those type processes to produce the part, not FDM printing. So FDM printing in this, you can make some cool shapes, and the topology optimization does still help, because it doesn't really create spiderwebby type models. It creates, you know, these lumpy models that you I wish I could show you, and maybe I'll get the license sorted out where I can show you next time. And if that's the case, we'll figure that out. I should be able to show you how Fusion 360 works, because I have a totally separate license for that. So like I said, the model that comes out of the SolidWorks one is really just a template. You could print it, but it's going to be very unattractive looking typically. And so normally what you do is you take that model as a template and create a new model around it using the guidelines of where it reduced area, and you just create a smaller area in your model in that spot, or smaller thickness. Well, I don't have, even though I wanted to do the topology optimization today, probably don't have enough time to open up Fusion 360 and do its generative design. That one I have to do ahead of time. This takes a long enough time, but how Fusion 360 works is it actually sends the model off to the cloud, and it does all the processing there, and it can take, you know, hours before it gets back to you. It doesn't necessarily take that long to do the simulation, but you're in a queue, and you know, depending on how long the queue is and how complex your model is, it's going to take some amount of time to get it back to you. So I probably won't be able to show on the fly how you actually get the model done. I'll have to prepare it ahead of time so that we can do kind of the cooking show thing, get it up to some point, and after that it comes back to you. Also, theirs is not always free. Obviously, SolidWorks is not free either. You have to have the license, which apparently I don't currently have, to make SolidWorks work as well. But Fusion 360, the education edition of it, or the what do they call it? I don't remember. It's not an education edition, but it's a small user type edition. Can sometimes charge you for the running the generative design. And I'll show you how that works next time. So I think we'll just close it down today. I don't know, because until I can actually click this button right here, I can't do anything. And so I got to figure out why that button is not active. And my other buttons, thermal, which I even have the, well, I have the flow simulation in here. I thought the flow simulation. So that's not really thermal. But we'll have to see what I've got not available, and it might be the license. So I will close it down today. On Monday, we'll either be doing SolidWorks topology optimization or printing ABS, ASA, or maybe we can do both. Maybe we can set up the SolidWorks, and then while it's doing its processing, we can look at the ABS printing. We'll at least do ABS printing one way or the other. I just don't know if we'll also be able to do SolidWorks. You know, depends. All right. Hopefully some of that was useful, at least informative, on some of the things that you can do. Hopefully we can get this SolidWorks to work so that we can actually simulate it, because it is interesting and a good thing to know how to do. All right. I'll see y'all on Monday and have something that we can look at.